Let's go back to 1984, before I got into TCP/IP. I was doing XNS and SNA, HDLC and those things at that time. But in the universities, they were doing TCP/IP, and Dr. Comer at Purdue had a DEC computer with 2 Ethernet interfaces. Why is ARP a 10-minute timer? Dr. Comer put 2 sets of students together who could take the deck down the fastest, change the Ethernet card, and bring it back up. That's why ARP has a 10-minute timer. So you have all this initial work which was being done there. And in his code, which we've all inherited, in the transport control block for TCP is the IP address of the interface. There actually was an implementation back at the same time that did not have this coupling, but Comer won. So in every implementation of TCP/IP that exists today, that the transport control block, the TCP connection, fate shares with the IP address. If the IP address changes, the TCP connection breaks. That's the way it is. That's by design, going all the way back. And even when we move from the stable PCs on the Ethernet or the and the mini computers on the Ethernet to where we got dial-up with PPP in the early 90s and then DHCP in the mid-90s, we never really got to that IP addresses became ephemeral. IP addresses became ephemeral in nature, yet we did nothing to address that TCP/IP fate shares with those IP addresses. That was one of the key things that we brought in with HIP. We did that decoupling. We made it so that now the application in the TCP is the hit, not the actual address of the interface. This is that ID locator separation. We just talked about extensively, but everybody tries to figure out, well, how am I going to do this? Oh, I don't want to do security. Security costs too much. Can I do without security? But then you come back to, no, I have to secure it. So it's a circular argument that I need the ID locator separation. I see I can do it securely. I don't want to pay for security to do it. But if I don't secure it, here's all the attacks. Oh, I'm going to have to secure it. And we keep on coming back to, if you want to do it, there's very few ways to do it, and HIP shows how this can be done. And it's really the only player in this field. Back in December of '98, as co-chair of IPsec work group, we made a presentation to the Malloc working group, which is multimedia. They had a 3-packet protocol, and we're telling them to take 18 packets to secure their 3 packets. I've never been so embarrassed in my life in technical presentations. We have to have a better, lighter way to offer security. So I went back and started thinking about how to do a lightweight security. That was the initial driver for HIP, was to do things lightweight. Along the way, realized that you can do something much greater, can create the concept of a secure endpoint identity, a provable IPv6 address. If there's any invention I have in HIP, it is the host identity tag. And this now enabled us to do mobility in a smart way, decoupling the transport from the internetworking layer so that the internetworking layer can change. It can go from v4 to v6. The application doesn't know, doesn't care at all about that. The device can disconnect from the network and connect somewhere else with a different address. No disruption at all to the application. That became the goal of HIP, to achieve that secure identity and the decoupling of the transport from the internetworking. We go back to the discussion, back to some original papers by Dr. Sulzer back in, I think, '85 at MIT. And some seminal papers that he wrote. Dr. Noel Chiappa was pushing this back in the original IP Next Generation work in the mid-90s. And what came called endpoint identity, which Dr. Steve Bellovin said, if you can't secure it, don't dare do it, because here are the attacks. HIP gave a way to do it in a secure manner. Now the discussion is even moving forward to what's called identity-oriented networking, where the identity of the device is key on the with the networking infrastructure being the transport, and we call identity locator separation. So the network deals with locator. Where is the device now in the network? Where identity says, it's this device I wish to speak to. So there's a number of different approaches to address this. HIP is the only one that puts the effort in solely in the endpoint and makes it a provable endpoint identity without requiring infrastructure, third-party services to assert the identity of the device. So moving forward, when we look at where 5G and the number of devices we're going to be having in the future and the movement to mobility, ION is a very important effort, and there will be multiple solutions for it. HIP will be one of the players in this new mobility world.